So last class we were discussing about decomposition of a schema, right? So whenever you decompose a relation schema, right, it should satisfy two conditions. One is going to be lossless join decomposition, and the second is like dependency preserving decomposition, right? So what are the conditions for checking whether a decomposition is a lossy join or lossless join decomposition? Dilip. So one of you can get me the answer. What are the conditions for checking whether the decomposition is a lossy or lossless join decomposition?
It's lossless if the union gives the original relation back. That's the first condition.
Right.
Second condition, the intersection of the relations, the divided relations should not be equal to null. And the third one is intersection of the divided relations should give back one of the super keys.
Right. Right. So correct, Saloni. Right. So these are the three conditions you need to check to check whether a decomposition is a lossy or lossless join decomposition. So the union of the fragmented relations should give you back the original relation, right? So the intersection value between the relation should be not null. Whenever you perform R1 intersection R2, it should not be null, not null. And the intersection of the fragmented relation should logically determine either R1 or R2. Right. So last class, I think we were solving few problems, and I think we had some problems with we had some issues with the last problem. So last problem, I think I was giving some wrong answer. I think my solution was wrong for the last problem. So I have requested Subramaniam to work for it, and I think now I request him to present the solution for that problem, and he will present some additional problems. Like we'll have some tutorial session. You can work on the problems. So I have also prepared some exercises for checking whether a decomposition is a lossy or lossless decomposition, and also for checking dependency preserving decomposition, right? So today we'll have some tutorial session, like you'll be given some problems. So initially Subramaniam will get you the solution for the problem, then we'll try to work on some problems and get the solutions. So I request Subramaniam to
Yes, sir. Sure,
come
sir.
forward, come forward and teach us, teach the
I'll share my screen, sir.
right.
Yeah. Is my screen visible, sir?
It's not visible, I think.
Not yet.
It's loading.
Yeah, now it's visible.
Okay. Yeah. So good morning, everyone. So I'll start with the conditions which Saloni already mentioned. So we have three conditions to make sure if the decomposition is lossless. So the first condition would be you have to take the union of the relations that are getting decomposed and check if that gives back the original relation. And the second condition would be you have to take the intersection of them and check if you have at least one element that is common between them. Basically, the intersection should not be null. And then the third one should be the intersection should give back the super key of either R1 or R2. The relations that you're taking the intersection of, you should give back either one of them to get it as a lossless decomposition. If it fails to satisfy any of the conditions, the decomposition will be lossy. So having that in mind, we'll move to the problem which we had solved the previous class. So are the problems visible?
Yes, yes.
Yeah.
Yeah, okay. So we have this relation starting from A till J, and then the functional dependencies of those relations are given as these are the five dependencies of that relation. and then the relation is getting decomposed into 5 relations, where R1 corresponds to ABCD, and then R2 we have DE, and then R3 we have BF, and then R4 we have FGH, and then R5 we have DIJ. So we have to check if this decomposition is lossless or is it lossy. So going ahead with the steps that we had seen previously. So the first step is you have to check for the union. So if you take the union of all 5 relations, it would give back R. So it satisfies the first condition. And then for step 2, we have to take the intersection. And since we have like more than 2 relations, we just take it one by one and then check simultaneously if that is satisfied. So we'll start with R1 and R2. So we have R1 as ABCD and then R2 as DE. So if you take the relation, if you take the intersection of it, it will be D. And there is a concept called closure where you have to take all the dependent elements corresponding to that particular element, which is the intersection. So taking D closure, as per the functional dependency given, D corresponds to IJ. So the closure of D would be a DIJ. And if we check the closure Dij, it is not a super key of either R1 or R2, which is the third condition that it must satisfy. So R1 is ABCD and Dij is not a super key of ABCD. And similarly, DE, so Dij is not a similar super key of DE as well. So the condition fails at this stage, but then we have an option of checking if we go by R5, will it be possible to get a lossless decomposition, since R5 gives Dij. So I've just tried the other method as well. If you go by R1 and R2, the problem ends in a single step since it doesn't satisfy the third condition. So I just checked for R1 and R5 by taking the intersection of them. Since we have the union set, we need not check it again. So R1 intersection R5 gives again D, because ABCD intersection Dij would again give D, and then we take the closure of it. And since the closure is Dij, it's the super key of R5 as well. So we satisfy all 3 conditions. So we can like merge those relations and then take it forward. Since we have 3 more relations to check, so we take R15 as ABCDIJ, which is this is just merging both relations, and then we take it forward. So we have R15, and then we have 3 more relations. So we'll go with R3, which is BF. And then if you take the intersection of them, it comes out to be B. And then B closure is seeing the functional dependencies. B gives F. So naturally, B and F should be in the same closure. And if we check the last dependency, F gives GH. So since we have B and F inside it, GH will also be included in the closure of B. So B closure would be BFGH. And as we can see, BFGH is clearly a super key of BF. So we satisfy that condition as well. So we have like 3 relations which satisfy all the conditions. So we again merge them, where R153 would give ABCD Fij. So we can see 3 elements are missing, which is E, G, and H to give the original relation. So we'll take R4 again and try to intersect and then check if it satisfies the conditions. So if you take R4, which is FGH, and then get the intersection of it with the original previous relation, we get the intersection as F. And taking the closure of F, again, as we saw, F gives GH, and there is no other dependency corresponding to F. So the closure of F would be FGH, which is clearly a super key of R4. And since we have all 3 conditions satisfied, we can go ahead merging them. And so we have R1534. We have merged all 4 relations, but then we have one element missing, which is E. So that's where we come to the last relation, which is R2, where we have E. And then so we take the relation that we've merged till now, and then we intersect it with DE. So the intersection of these 2 would be D. And then as we've seen already, the closure of D would be Dij. And as we've seen in the first step, where we took R1 and R2 and took their intersection, we are sure that Dij is again not a super key of either DE as well as the whole relation, which is ABCD, FG, H, IJ. So as we've seen, even if we merge all 4 relations, the relation R2 is not, we aren't able to get we aren't able to merge the relation R2, and since we aren't able to merge the relation R2, E does not E is not there in the final relation that we have, which is A, B, C, D, F, G, H, I, J. And since we don't have that, it's not equal to the original relation which is given in the question. And because of all those conditions, the whole decomposition which happens is lossy. So yeah, that's this problem. If you have any doubts in that, feel free to ask. Else, I'll move ahead to the other problem.
Go up a page, please.
Yeah, sure. This one?
Yeah, the bottom of this page. 1 second, stop this.
Okay.
Yeah, can you move down again? Sorry.
Sorry?
Can you move down?
Sure. Yeah.
Are we sure, like, D closure here cannot identify ABCD, R1534 uniquely? Like, is it not a super key? Are we sure?
Yeah. Super key should contain all the elements that we have in that particular relation.
But I think we were considering super key as any key that identifies any of the decomposed relations, before. I'm not sure, but at one step we're ending at Dij. So are you
Yeah,
sure that qualifies?
we started with R15, and since only R5, basically the closure that we get should be the super key of either one of the relations that we intersect. So since both the relations that we have over here, Dij is not a super key of that, because if you see that super key, it should have all the elements. It can have different elements as well, but then it should have all the elements that's there in either one of the particular relations. So since we have
so if it was DEIJ, then we could have considered it, right?
yeah, if it was DEIJ, we have DE, and DEIJ
R2 would
is
have
the
been
super key
okay.
of,
Okay.
yeah. So since we don't have E in any of the closures, it's not to be considered as a super key.
You mean DEIJ, if DEIJ is D closure?
Yeah.
Yeah. If it was
Then
DE
it is
closure,
a super
then
key.
R2 would have
Then
been
even then you
considered.
don't have DEIJ on either side, right?
No, but
No,
DE
but
is there, right? For
No,
R2.
you have DE in R2,
It can
right?
be either
So,
for relation 1 or relation 2. Either one of them.
Okay.
yeah, I think we can see questions.
sure, cool. So I'll explain one another problem and then ask you people to solve the rest. So I'll just start with this. We have the relation as A, B, C, D, E, and then we have three functional dependencies for it. And then we've given the decomposition as R1 corresponds to A, B, C, and then R2, B, C, D, and then R3 we have as C, D, E. So again, going as per the steps that we've seen for the last problem, we'll take the union of it and check if it if it's equal to R. So since we take the union of all three, it's A, B, C, D, which is the original relation. It satisfies step 1. And then for step 2, we again take intersection in steps. So we'll start with R1 and R2. So taking the intersection of R1 and R2, we see that the intersection is DC. And then the closure of DC is, there is no closure separately for, there's no dependency separately for B. So we'll take only the closure corresponding to C. So we have C gives D. So the closure of DC would be BCD. And we see it's the super key of R2 because it's basically the same of R2. So we satisfy that condition as well. So we'll try merging them and then check with the other relation. So R12 will give ABCD. And then we take R12 and then we intersect it with R3. So taking that, we see the intersection would be CD. And then again, looking at the dependencies, C gives D. So again, the closure of CD would be again CD. But as we've seen, both the relations above, which is ABCD and then CDE, CD is not a super key of either of them. So it does not satisfy that the third condition which it must satisfy for it to be lossless. So the decomposition is lossy again. Yeah. So now are you people clear with how the super key works and how we check for lossy and lossless?
Yeah, kind of.
Okay, so I have two problems which you people can try and maybe solving. I'll give the solution at the end, but you people can start maybe solving the problem. So this is the problem. We have the relation with A, B, C, D, E, F, and then the functional dependencies are given as such. And the first decomposition is it decomposes into three relations, R1, R2, and R3, which is given as A, B, C, C, D, E, and then E, F. So you can solve and maybe tell if it's lossless or lossy.
Right. So thank you, Subramaniam, for your a nice presentation. So in DBMS, in GATE exams, or in maybe in your placements, whenever you have some problems in database management systems, you can expect some problems in normalization. So I would like everyone to take a piece of paper, pen, try to solve the problem. Right. So I think we have two more problems, and you are expected to solve it and give the solution.
Is it lossless decomposition?
Yeah, it is lossless.
Okay.
So,
yeah. So
yeah,
can I
if you are
say?
gonna explain, yeah, sure.
Okay. So the first condition union that is satisfied, ABC union CDE union EF, that gives us original relation, and then R1 intersection R2 will be C, and then C closure will be ABCDEF, and the entire thing, it can be a super key of R1 also and R2 also. So we'll move on from there, and then we'll find R1 R2, and R1 R2 is ABCDE, and then intersection with EF, and intersection will give us E, and E's closure will be AEF, and AEF is again, it can be a super key of R3. So that way it should be lossless.
Yeah, exactly. So as Supriya said, R12 satisfies the conditions, and then intersecting it with 3. Again, we have that as the super key of R3. So since it satisfies all 3 conditions across all relations, the decomposition is lossless. So so we can move ahead to the last problem which we have. So the last problem, again, it's the same relation and the same functional dependency, only the decompositions vary. So you can go ahead noting down the decompositions. We have 4 decompositions now, 4 relations, which is AB, ABC, BCD, and then DEF. So anyone can try that and maybe explain.
Wait, can you show the relations go up?
Sure, yeah. Can I move down to the decompositions?
Yes.
Sure. Yeah.
Yeah, is this lossless?
Yeah, it is.
Okay, so we can take the first 2. So first of all, first condition satisfied because union is A, B, C, D, E, F, right?
Yeah.
Okay. And then first 2 relations taking R1 and R2, we get intersection as AB. Closure of
Yes.
AB is A, B, C, D. So it is a super key of ABC or AB. So that is satisfied.
Wait, Saloni, 1 second. So closure of AB is A, B, C, D, E, F, because as we see,
Yeah.
D can reach EF as well.
Yeah,
D can reach E, F as well. So yeah.
No,
so,
it doesn't matter once we have ABC, right? So
yeah, sure. But then
yeah. So then taking R1 and R2, so we have ABC. Then I intersect it with R3, which is BCD. So ABC and BCD, the intersection is BC, and closure of BC is BCDEF. A.
again, yeah, okay.
Yeah. So that is also a super key of BCD or ABC. Then going on with R1, 2, 3, intersection R4, we have ABCD, intersection DEF, which intersection is D, and D closure will be DBEF. Yeah. So which is also a super key of DEF or the first relation.
Again, even in D closure, you will
E,
have
B, E, F, A
all,
also.
Yeah.
A also,
all
yeah.
6. So again, it will be
How
a
does
super key
B
of.
come in? How does B come in D closure?
D gives B.
Okay.
Yeah.
D gives EF, and then F
D
gives
gives
A.
B as well in second
Yeah,
last.
D gives B as well, and then AB gives C. So we have all 6. Yes, so that's the explanation for this problem, and again, it is the decomposition is lossless. So yeah, that's it from me. So if you have any doubts in any of the problems that we solved, feel free to ask me. Else yeah, I'm done.
Thank you, Subramaniam. You can upload this PDF in course materials folder so that others can access it and they can go through it.
Sure, sir. Can I stop presenting, sir, if no one has any doubts?
Yes, Subramaniam. I think no one has doubts.
Okay, sir. Thank you, sir.